We're going to work these out together, these bottom four, because they're just the word type equations. And then I will give you the homework with one more example on it. So we'll have about 5 examples with that. I'm going to turn the lights on so you guys can. At the bottom of page 8 in your notes, I think it's bottom of page 8. We're doing the same thing today. The only thing that we're changing is instead of giving you the balance formula, you get to write the balance formula. That's why you want to know your 52 elements, names and symbols. You want to know your polyatomics. Make sure that you can still balance the chemical formula, and then we'll balance the chemical equation. Doesn't that sound like fun? All right, 1G. It says when copper 2 carbonate is heated, it forms copper 2 oxide and carbon dioxide gas. Oh boy. So how do I write copper 2 carbonate? Well, copper is Cu. And what's the Roman numeral 2 mean again? Has a charge of +2. So if it doesn't have a charge, and you might want to get your periodic tables out if you don't have them out already. If it doesn't have a charge or a Roman numeral given, then it only has a single charge. But if it has a Roman numeral, it's telling you what the charge on that metal is. Okay. And then carbonate. What's the formula for carbonate? CO3. Good. And what's the charge on carbonate? -2. So is that balanced as written?
Yes.
Yeah. So we have a +2, -2. So copper 2 carbonate is CuCO3. Okay. And again, we did that before Thanksgiving? I can't remember. All right, so it says is heated, it forms, so arrow. Copper 2 oxide, so again, the charge on the copper remains the same, and it won't change until we start doing redox equations. So I'll make sure that I let you know what that is a little bit later on here. So copper has a +2 charge. Now when it says copper 2, so copper 2 oxide, so how do I write that? What's the oxide portion of that? The O. And what's the charge on the oxygen? -2. So far so good. This is really turning out to be nice. And forms carbon dioxide gas. What's carbon dioxide? Good. And the reason why it has the di in there is because we have a nonmetal with a nonmetal. Now, this is going to bum you out, but can anybody tell me if that's balanced or not?
No, probably not.
Yeah. Really? Copper, copper, 1 carbon, 1 carbon, 3 oxygen, 3 oxygen. So and again, you'll get to that point. But if you can't see it yet, then do the inventory method. So I've got 1 there. Oops, sorry. 1 there, 1 carbon. Oxygen 3.
Oh, I get it.
Yeah. So when those are the same, it's balanced. So in this case, it's balanced as written. Okay. And sometimes that happens from word form. And if you didn't write these correctly, maybe you, for whatever reason, you put a 2 in there, then that really messes things up. But there shouldn't be a 2 there. Yeah. So again, the hardest part of this is making sure that you can write the chemical formulas, which hopefully shouldn't be too much of an issue. Looking at 1H, it says sodium reacts with water to produce sodium hydroxide and hydrogen gas. So how do I write sodium? Na. Reacts with water, so hopefully you can do water, to produce arrow. Sodium hydroxide, so again, what's hydroxide? OH. And hydrogen gas. And again, remember, since it ends in gen, then it should be diatomic. Okay. And actually, so again, this is diatomic because it ends in gen, and the other ones are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and good old iodine. Okay. Now, these are not all gases. Actually, these are gases at room temperature. That's a liquid and that's a solid. Okay. So don't automatically go, oh yeah, gases, they're diatomic. No, just make sure that it ends in either gen or ine. Alright. Now, charges on the sodium hydroxide. What's the charge on sodium? +1. Hydroxide? -1. Good. And so it's balanced as written formula-wise, but let's make sure that we have the same number of atoms. So again, sodium, we have 1, hydrogen, we have 2, oxygen, we have 1. Sodium, we have 1, hydrogen, we have 3, and oxygen, we have 1.
Sorry.
Yeah.
Why do you not do the charges on the other ones?
These don't have any charges. Okay, when they're by themselves, and have we talked about that already? When they're by themselves, it shouldn't have a charge. And I always say this, you should always get excited or charged when you're with somebody else. You shouldn't ever get excited when you're by yourself.
Because you have no friends.
Right, there we go. I like that. That's good. Okay? So the only time that you should have a charge or be excited is when you're with something else. Okay?
So what about that one?
This one, water. Yeah. I mean, it's HOH, -1 + 1. I'm assuming that everybody knows the formula for water. Probably shouldn't in this class.
Wait, what? No, wait, sorry, I was just what?
Huh?
Shouldn't put
What?
what in water?
No, nothing. Yeah. So we have the formula, or the formulas written down correctly, and that's the first thing that we have to do right. So again, and I think we worked this one out yesterday. This one seems like a little bit of deja vu here.
Do you think?
I don't know. Put a 2 there, right? And so that gives us how many hydrogens?
4.
And how many oxygen? 2. This looks, so we need to put a 2 in front of this. That'll give us 4 of those and 2 of those. So how do I balance the sodium? Put a 2 there. I know we did that yesterday.
No, we did not.
We didn't?
We did.
Okay. All right. 1I. It says copper combines with sulfur. All right. So copper combines with sulfur, and to form copper 1 sulfide. So how do I write copper 1 sulfide? What's the charge on copper? +1. Good. Sulfur? What is it? -2. Good. So that's not balanced as written, so we need a 2 there. Do I need to do inventory on this one? Yeah? Okay. What do I need?
Put it 2.
There you go. Last one's a little interesting. Silver nitrate. How do I write silver nitrate? AG, good. There's no G in gold, so the silver. And nitrate? NO3. What's the charge on silver? It only has a single charge.
1.
+1. Nitrate? -1. So it's balanced as written. Reacts with sulfuric acid, which you don't know about yet, H2SO4, to produce silver sulfate. How do I write silver sulfate? Well, obviously silver is Ag, and sulfate, SO4. Yeah, I kind of gave it away there.
But doesn't that have a negative?
It has a negative who?
Is it 3 or is it 1?
Neither.
2?
2, good. So that means we need 2 of these, right? 2 silvers to balance the charge. Right?
Yes.
And then nitric acid. I don't know why I gave you nitric acid and not the other one. Okay. All right. So that one's a little more interesting. Let's see, we've got silver, one of those nitrogens, we've got 1. Oxygen, we have how many? 7. Sulfur, we have 1. And hydrogen, 2. Now, you don't have to go in that order. I don't know why I went in that order, to be honest, but oh well. Try to keep it in the same order on this side, so we have 2 of those, 1 of those, Oxygen we have 7. Sulfur we have 1. And hydrogen we have 1. So, what do we need to do?
Hold on.
Hold on. Okay. I'll brace.
Can we do the silvers first?
We can do the silvers first. So there's 2 over there, 1 over here, so let's put a 2 there. So now that gives us 2 silver. And it also affects the nitrogen and oxygen. So how many nitrogens do we now have?
2.
2 on the left. And how many total oxygen do we now have?
10.
2 times 3 plus 4, which is 10. Good. Okay. Well, the silvers are happy, but, and other than sulfur, it's happy. So what do we need to do to the nitrogen? Put a 2 in front of here. So now that gives us how many hydrogen? 2. That's a good number. Nitrogen we now have 2. Oxygen we now have 10, and we're balanced.
Oh.
Can I give you a really ugly one that's not on here? But you could put it like in your margin here or margin down there or somewhere in between there. What the heck? And let's make sure it's not on the homework.
Maddie, did you just hear her? I said, Maddie
Wait, isn't that what, that's what it means in a roundabout way.
No.
Alright. Here's another one. And the way this would be worded is that we have sodium carbonate reacts with iron 3 phosphate to produce sodium phosphate and iron 3 carbonate. Okay. Now again on the carbon hydrogen compounds, there is no shortcut. The inventory is really the only other way to do this. However, with something like this is pretty ugly. Okay, there's a lot of different elements in there. There's sodium, carbon, oxygen, iron, phosphorus. There's a lot going on. However, what I do want you to recognize is that we have polys. Okay, if you see the polyatomics and they don't change, even though we have that in parentheses, treat the polys as a whole. Okay, don't break it up into like oxygen, because oxygen's in every single one of these. So if you treat it like a poly, it gets a little simpler. So now we have sodium and carbonate. We all have iron and phosphate.
But
Okay.
you could do it the other way, right?
Yes. Oh yeah. Yeah. But you're going to find out this is a lot easier. Okay.
Can you only do this on ones that are?
And honestly, I'm not even going to give you an inventory.
Oh no.
Oh yeah. I'm not even going to show you the
I just
inventory.
like right
Okay. And here's how you do it. Let's do this. And I started to say this yesterday. I don't know if I said it in your class, but this is ugly. Go ugly early is what I always say on something like this. Okay, I've got 2 metals, I've got 3 non-metals, where everybody else is either like 1, 1, and again, I'm counting how many polyatomics. So, how many carbonates do I have here?
9.
Carbonates, CO3s. 3. How many carbonates do I have here?
1.
Just 1. Yeah, there's just 1, because there's not a parentheses. So if there's only 1 carbonate on here, and there's 3 carbonates here, then I'm going to put a 3 in front of that. So I have the same number of carbonates on both sides, right? CO3s. Okay. You can, yeah. Now, how many sodiums do I have? 6. How many sodiums do I have here? 3. How can I get 6? Put a 2 there. Okay. See how I'm doing that? So I start here, start with one of them, and go ugly early. Okay? You got a balance? Okay. So now I've got 6 sodiums, How many phosphates do I now have? 2. How many phosphates do I have here? Put a 2 there. Am I done?
Yes.
Yeah.
Yeah. Okay. So you can look at it that way, and it's pretty easy that way, actually. But keep them as your polys. And if you need to box them in just so you can visualize it, nothing wrong with that. Now, if you still want to do the inventory with each element, that's okay. Right. So the one example says that we have magnesium metal. How do I write magnesium metal? Mg, yeah.
You tell me.
I'd still write it the same way if I called it solid magnesium, or liquid magnesium, or gaseous magnesium. Still Mg, okay? Magnesium is magnesium, period, okay? Reacts with, that means plus, reacts with, nickel 3 nitrate. How do I write that? Nickel 3 nitrate. Ni, good. NO3, nickel nitrate, okay? However, the nickel has what charge? Plus 3 because it has a Roman numeral 3. What's the charge on nitrate? -1, so that means I need what? Parentheses 3, right? Good. Okay. To form, arrow, magnesium nitrate, so magnesium and nitrate again. What's the charge on magnesium? Plus 2, and nitrate is still -1. So is that balanced?
No.
No. So I need 2 of those, and nickel metal. Okay. Do you want to do inventory or what I just showed you? Just showed you? Okay. Really, there is no ugly one, really ugly one. So I don't care, pick one. Start with that one?
Yes.
Okay, so there's 3 nitrates, 2 nitrates. How do I get the same number of nitrates?
2 to 3.
Yeah, so put a 3 there and a 2 there. Okay, so I know my nitrates are the same, the NO3s. Okay, if you want to look at the magnesium, how many magnesiums do you have? 3. How many do I have here?
1.
What do I need? 3. There you go. How many nickels do I have? 2.
Oh.
And again, if you still need to use the inventory, that's fine. Okay. But I would highly recommend that if you have the hydrocarbons, and did I give you any? Correct. I don't think I gave you any on this. Okay. So I don't think there's any CHs on this one. Okay. So for today, this is what you're doing. Okay. You're writing out the chemical formulas and then balancing them. Okay. But before you start balancing the number of atoms, make sure your formulas are written correctly. And don't forget if it's diatomic when it's by itself. Again, hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, okay, and iodine. And don't forget about your polys. What are the 10 polys? What's this one? Acetate. I'm trying to go in order, but I don't know if I'll get it in exact order. What's this one? Nitrate. What is this one? Iodate. What is, so I know I'm not in alphabetical order now. What is that? Chlorate?
Carbonate.
Hold on, we got one more OH. Or -1, hydroxide. And I think that's all the -1s. Okay. And then I heard a carbonate.
Yeah.
So CO3 -2. Any more -2s?
Phosphate. Yeah.
Chromate, I heard. Okay. And phosphate's -3. Sulfate, good. Any more -2s?
No.
No. Then the phosphate,
And then you got the stupid ammonia.
ammonium, good, NH4. The only metal, okay? So make sure that you know the name, the formula, and the charge. Okay? On your homework, and I'm recording this as well, but on your homework in number 5, that's hydrochloric acid. In number 6, that's phosphoric acid. In number 7, that's sulfuric acid. And we haven't talked about the acids yet, so I'll give you the names for those. So again, hydrochloric, phosphoric, and sulfuric. Okay. Yeah.